Great, thank you, Steve. Let's get this going. All right, cool. All right. Never migrate storage again. Probably, maybe. Um, first off, brief introduction. My name is Andrew Sanders. I am a systems architect at UNC Greensboro. I've been at UNCG for about 7 years. Prior to that, I was at Appalachian State for 5 years before that. And my primary focus at UNCG is on endpoint management, running our SCCM environment in Jamf, and also our core on-prem Microsoft technologies, mainly Active Directory and our M365 environment. So, agenda on what we're going to talk about today. So this session is going to focus on Azure Files and how we used it, or how we are using it to um, hold a good bit of our network file storage. So we'll talk about kind of the architecture and goals, like why we went the way we went, how we implemented Azure Files, how we migrated to it, and then finally some numbers. And those numbers will include costs. I will show you what we are paying, because I know that's always a big topic when we talk about cloud things. So I will be showing that at the end. And then at the end, we probably should have some time for some Q and A. We pull there we go. So kind of run through some of the architecture that we went with, goals, why we kind of went with this. So the way we did look prior to this, prior to moving some of our stuff to Azure Files, so we had two SANs. We had one for academic and research, and one for everything else. So the academic and research held everything for all of our academic departments, and any research data that needed to use network file storage. You can see the amounts there: 11 terabytes on the academic side and 8 terabytes on the everything else side. We used DFS to present both of those SANs as a single network storage name. We branded that as My Files. So if you hear me saying My Files throughout this talk, that's what I'm talking about. It's kind of how we branded our network file storage. We only did the academic side to Azure Files so far. And the primary reason for that is they were under different maintenance contracts. When we started out this migration of the academic side to Azure Files, the maintenance contracts were December 31st of this year for the academic SAN, and the everything else SAN was December next year. That everything else has since been extended to 2025 for other reasons that we won't talk about here, but the kind of the why we split this and why we are half in Azure Files, half not, mainly dealt with the fact that the maintenance contracts were different on the SANs. So kind of the goals here. So looking at what we were going to do with the story, with the files and folders that were on the SAN going out of maintenance. Kind of the things we were going to look at. We knew we needed to migrate to something new because the old one was going to be out of support. We really wanted to focus on cloud first. That's been a strategic goal for UNCG since 2017. That anytime we do something new, we first look at cloud technologies to see if there's a cloud technology that can meet the needs of what we want to do. We wanted to limit client impact during the migration. And potentially in future migrations. If anybody has ever done a storage migration before from one SAN to another, or one system to another, you know that they are not usually, they don't usually have low client impact. They're usually very impactful. Storage is down for some amount of time, and folks can't access their files, and that whole story, and trying to move everything, move permissions, move the whacked out stuff that users have done in there for the last however many years. It's normally carries some level of impact. And then of course, if we could do a solution that is cheap, that's always good, saving the university money, kind of wherever we can. So why did we pick Azure Files. It's cloud first. Obviously, all of the files are stored in the cloud. They're stored in Azure Files in an Azure file share. We did do a local cache of hot files. So this is two Windows servers. We'll talk about the architecture more in a minute, but basically it's two Windows servers configured in a HA like. They're not completely HA, but they're almost completely HA pair. So there's two of them. That provides local redundancy for files backed up by the cloud. That local redundancy really means that files are quick, right? Our users didn't notice a difference between access times and write times and things like that, where we were and where we are now. So it's very, very fast doing it this way with a local cache of hot files. All a client sees, whether that be Windows, Mac, or Linux, all clients see is a Windows file share. They don't see the fact that the files are in Azure Files. So you get all of the same benefits of normal Windows file share. So we have quotas, shadow copies, NFS for Linux. So you get all of those things kind of with this when you do the on-prem servers as well as the Azure Files, and it is significantly cheaper than a new SAN. I don't even think we really priced one because once we kind of ran the Azure calculator, we realized it probably wouldn't compete. I'm assuming that what we'd have been looking at it had been in the 100 to 150K, 200K range. And what we did is significantly cheaper, and I'll show that at the end when we look at costs. So implementing Azure Files. So some of the requirements for actually doing this. So in Azure, the requirements that you have are you need a storage account and a file share inside of the storage account. You need a storage sync service with a sync group. You need VPN or ExpressRoute and private endpoints. The private endpoints I don't think are actually a requirement, but you probably want that so the traffic's not going across the internet, right? The private endpoint is how you make sure it goes over the VPN or ExpressRoute instead of out over the public internet. So it's just real basic requirements. On-prem, how we set this up, a Windows server or servers with the Azure File Sync agent installed, and the system account or whatever account runs the sync agent has to be added to the sync directory with full control rights. This is kind of a key point that kind of tripped us up a little bit during our migration. And we knew going in that this would happen, but we had to change permissions on the files once they were migrated off of the old SAN to add this so the sync agent could read the directories and actually do its syncing job. So this is what the architecture for us looks like. So clients connect to the DFS server, which has now I'm drawing a blank on what it's called. A namespace. There we go. Has a namespace on it called My Files that has two folders under it: user and group. The user folder are home directories. They're traditional, user home directories, and the group space is where the department or research kind of shared files exist. The user space primarily communicates with server number 1, and the group space primarily communicates with server number 2, and then both of those sync over our ExpressRoute into Azure Files. The kind of cross-link here, so group dotted line to 1 and user dotted line to 2. In DFS, how we have that configured is they are actually configured as part of the user namespace, but it's just like 02 is the last target, and that's where we get a little bit of the HA from. Whereas if we want folks connecting through the user directory to talk to 01 unless 01 is not available, and the same with group space and 02. The reason why these aren't just solid lines and using two servers, and why this isn't completely HA, is that we found that when you're running the Azure Sync agent, and I think this is a little bit of a difference between DFSR and how the Azure Sync agent runs, is if I have a file open and I'm connected to server number 1, and Steve opens the same file, and Steve is connected to server number 2, the two servers don't know that the file is open on both of them. So you get kind of a race condition on saving a file. So like if I'm in one area of the document editing it, and Steve is in another area of the document editing it, and I save it, and then Steve saves it, then Steve's copy is going to win, and everything I did is going to be wiped away. So like that was really important, and so that was really important to kind of keep in mind. So we wanted, 99.9% of the time for folks to be connected to the same server, same folder, same file to kind of prevent that from happening. But we did kind of the cross-linking here to provide a little bit of that HA in case, like I said, 1 is down or 2 is down. I'm going to stop for just a second if there's a question. So this account does not need to be an Azure managed account for the file copy down to on-prem. No, it does not. The sync agent communicates with Azure Files via something else. I don't know what that is. I don't recall what that is off the top of my head, but it's doing that sync some other way through some other account. Did y'all test this without ExpressRoute? We did not test it without ExpressRoute. We were going to use ExpressRoute the whole time, so we did not test that. I don't know why I highlighted that in red, so we're just going to move on. So those those two servers that we're running on-prem, just kind of real quick on how we have those configured. There's a Microsoft sizing document in the Microsoft Learn site that says, if you have this many files, your server needs to be this big. So that's how big we made our servers. We had enough files to where the servers needed to be 16 cores with 64 gigs of memory. The data drive size is just all about how much local cache you want to have. We went with 3 terabytes because it's roughly a quarter of the total size of the share that we were doing. So we just went with 3 terabytes. That can really, like I said, be any size that you want it to be, depending on how many files you want, how much local cache you want. Both the servers are running the File Server Resource Manager and Server for NFS server roles. The File Server Resource Manager is what allows you to put quotas on folders. We want quotas on folders, and Server for NFS allows for easier connection to Linux. So we did have a couple Linux boxes that needed to use this space, so we turned that on as well. We do have access-based enumeration enabled, so users only see what they have access to, and volume shadow service is enabled, so clients can do their own self-restores of files, through Windows Explorer. And this last point is key. You don't want to back up these servers. I guess you can if you want to, but there's really no real point to doing that. So we're not backing them up. The backup is done in the cloud on the Azure file share, and we're just doing that with regular Azure backup. I think you can do that with other services, Rubrik or Veeam or whatever you got up there, but we just did it with Azure backup because it's easy. So that's how the servers are configured. So the migration process. So this is kind of what our architecture looked like during the migration. So one of the challenges that we faced was getting files from the SAN that we had into Azure Files. And so while also trying to limit client downtime. So the way we did that is initially, so the configuration prior to introducing any of this was kind of that bottom row. So it was the DFS server, the My Files to user and group, to the academic SAN. That's what the architecture looked like prior to this. So what we did is we introduced a third sync server into the mix that had enough file storage to have everything that was on the academic SAN copied to it. So that server had a 20, I think it had a 20 terabyte data drive attached to it. So we robocopied everything to that server, and then turned on the Azure file sync. And once we turned on the Azure file sync, it started syncing up to Azure Files and then back down to the other two servers based on how we wanted the cache to work. That's kind of how we because you can't, because right, that file sync agent has to be installed on something, and you can't install that agent on the SAN itself, right? So we copied everything to a Windows server that we could install the agent on. This whole process took about 10 days. The robocopy over to the migration server took about 2 days, and then it took about 8 days for Azure to sync everything up and then sync it back down and get all the cache and kind of all that stuff right. Yeah, so well, yeah. So I did skip a couple steps. I'm glad my slides reminded me of that. So we did set up the environment first. So you build the share and set up the sync agents, those sorts of things. Then we turned off the sync agent on all three servers while we did the robocopy. That was because we had to get everything robocopied and then the permissions set back up right so that the system account or the account that runs the file sync agent was had access to all the files. So that was part of it too. And then robocopied all the data, talked about that, applied the right permissions, and then enabled the sync agent. I kind of already talked about this. And then there we were. So this is just kind of that in Word form. So skip that. So then we planned a cutover weekend. And so, we had everything robocopied over. While all that was going on, clients were still connecting to the old SAN and using the old SAN. So on our cutover weekend, we basically did a cutover, right? We disabled the DFS targets to the old SAN, reran a robocopy. That pulled everything over. We had ran a robocopy earlier in that week too, just to make the robocopy during cutover weekend as fast as possible. So we did that robocopy and then changed the DFS targets to the file sync servers. That's what we did. It was pretty easy. This whole process only took maybe 2 hours, and I did it late on a Friday night, so nobody really even kind of noticed what was going on. So again, this is architecturally what it was supposed to look like. So that is what was supposed to happen. We had a little snag that I will talk about too, so that you don't suffer the same fate I suffered. Right before we were getting ready to cut over, I realized that our file permissions were not correct. And so I thought I would be real fancy, and instead of just letting Azure sync everything up and it taking a couple of days, I would go in and fix the permissions on. I would turn off the sync agents, go in and fix the permissions on all three servers, and then turn the sync agents back on, and Azure would just be happy. Nothing, it wouldn't see any changes. It would just be happy, and everything would be happy. That is not what happened. It completely completely messed everything up. It's just like it was just a mess. Azure saw, instead of seeing nothing had changed, Azure saw everything had changed on all three servers and started trying to sync and do all this stuff. So take it from me, don't try to trick the agents into doing something. Just let it do its let it do its business. I should have just changed it on one and just let Azure spend a day or two fixing everything. So don't try to do that. So where we actually ended up on migration weekend is we look like this. The DFS server was just pointed at the migration server. Everything was there. Everything was good. It took Azure probably about 2 weeks to catch everything up. And then once it caught everything up, we spent a change, we did a change window and redid the DFS targets like this. Which is how it's supposed to be and how it's running today. So that was a fun couple of days, weekend, trying to oh no, why did I do this kind of thing. So now we'll talk about some numbers on what we did or what we moved, what it looks like today. So we moved right at 11 terabytes, 12.5 million files that we migrated into this. In the last 30 days, we've seen 425,500 files roughly synced around between the servers and up into Azure Files. Um, uh, 30 days was as far back as I could make the report in Azure go. I thought it would go back further than that, but that was all as far back as I can make it go when I was updating this the other day. So that's what we've seen. Today, we've got almost 11.5 terabytes in Azure Files and 2.2 terabytes cached locally on those two servers. If you remember, those two servers have 3 terabyte drives, so the other 700 gigs is for the volume shadow service. And just make sure we don't fill the whole drive up. So that's what the other parts of those drives are for. And then so cost, because I know this is always a big one. So we started all of this. This only goes back to July because this July is the month where we started all of this. So that $3,000 roughly bill in July was the sync. So when you're in Azure Files, you pay for the storage and you pay for the transactions. So there were a ton of transactions. There were 12.5 million transactions. That's the number of files we did. So there were at least that many. Actually, I think there might be 3 times that because there are 3 servers. I don't know, but that's the transactions and the storage. So we knew July was going to be high. August, same thing. Our cutover weekend was in August, so we had some more syncs and some more, large data moves in August, but you kind of see significantly less. And then September, October is kind of what we're targeting to be what we pay monthly going forward, somewhere around the $900 average $900 mark a month. So you kind of run that out, and that is, I think, significantly cheaper than buying a new SAN. Not $900 a month. That's, what's that? That's $11,000 a year or so. So a lot cheaper than a new SAN. So the again, this is what we're seeing with that cost. So you can kind of multiply that out for your environment or divide it out if you have a smaller environment, and probably kind of zero in on relative cost that you would kind of see. So the title of this was Never Migrate Storage Again. So how did this get us to that point? And how what was the benefit of doing it this way? So all of our files are in the cloud. I don't have to worry about where the files are stored anymore. I don't have to worry about that hardware. I don't have to move my entire set of files from one place to another place probably ever again, because probably the real future of this is almost all of this or most of this be moved to OneDrive or something else anyway eventually. So I don't ever have to worry about the underlying storage where all of this stuff is stored anymore anyway. And then DFS plus the Azure File Sync really gets us to the point where who cares about the cache servers, right? One of those servers could crash tomorrow. I have our VMware engineers spin up a new one, install the sync agent on it, and we're back in business in under a day. And the whole time, everybody's talking to the other server and and using it. If both of those servers failed, DFS can be pointed directly to Azure Files, right? I don't even need the cache servers. I can make DFS go straight to the Azure File Share, and it would probably be a little slow for folks, but it would at least work until we got the cache servers rebuilt. So those servers run. The cache servers run server 2019 today. When I'm ready to move them to 2022 or 2024 or whatever the next version is, I just add one to the environment and change DFS to point to it. Right, there's no downtime, no impact, or very very small amount of downtime or impact. So that's kind of where this came from. Is I don't really ever have to migrate storage. I don't ever have to do these big huge copies. And I don't really have to impact my users anymore or at least I don't foresee having to impact our users anymore with trying to switch some of this stuff around. So, and with that, if there are any questions, I will take them. So yeah, are your Azure backup costs contained? No, they are not, and I should have pulled that, and I did not. So I apologize, Richard, but no, they are not. They are not included in the costs I displayed.
And just as an FYI, I did take everybody off of mute, so or give everybody the ability to come off of mute. So if you have a question, just raise your hand, and then Andrew can call on you. Come on, somebody has to have a question.
Go ahead, Richard.
I always have questions, but Andrew
There you
knows that. So you were saying you didn't. Were you communicating your total cost of ownership with the backups to your leadership as like the total cost of this exercise, or were you driving your narrative for the backup costs in a different direction?
We never really had a conversation about backup costs. Like we did the Azure calculator on this before we did anything. Yeah, just the standard public facing Azure calculator, and it was coming in at, that doesn't take into account in any educational discounts or anything we get for data and education, but it was coming in at, like, you plug in your storage, your amount of storage, and the number of transactions you think you're going to have, and it was spitting out for us like $1,200 or $1,300 a month or something like that, and obviously we're under that. And so, like, when we saw that, and then when we saw what we thought a new SAN was going to cost, there really wasn't a question.
Yeah, it makes sense.
I mean, even with the backup costs, right? I don't know what they are, but I mean, they're probably they're probably pennies, right? But
yeah, it's probably nothing. I was just curious the way it's going, because we've built up the narrative over time about, well, the cost for this hardware also includes the backups that we've got to do whenever we talk about storage. So every time we talk about changing it, that becomes part of the discussion. I didn't know if you guys had moved the backup costs to a different narrative point. Just curious.
No, I don't think so.
Okay, cool. Thanks.
Chris?
What storage tier did you use?
These are sitting in hot.
Okay.
Yep. There was a question.
Did you test it all with cool, or?
We did our development in cool and saw a little bit of lag, and so I think that's why we did hot. I think we're going to come back and revisit it, maybe at some point, or when we look to move the rest of our network storage up there. But yeah, we just went with hot.
Okay.
There was a question in the chat: if you potentially calculated the cost of pulling 11 terabytes on-prem in the event of a catastrophic failure. We have not. We have not looked at that. No.
All right. Well, if there's any other questions, please come off mute or type them in the chat window. If not, we'd appreciate it if you take a moment or two to fill out the feedback form that Caden's posted in the chat window. And Andrew, again, thanks again for your leadership and for your insights, and appreciate the session. And I'm going to end the. Oh, looks like Philip has a question. Always wait for Mr. Swansea to show up later.
Andrew, just one quick question was, did you guys test or try hosting your Azure data center storage in two different zones, like East and West, or did you just stay in East? Or
yeah, we stayed in East. Yeah, it's only in one zone. So just a little bit of so network storage at UNCG is not our primary. It's not build as our primary storage platform. Our primary and recommended storage platforms are cloud platforms. So it's Google and Box, and soon to be OneDrive. And so when we built this, that's kind of the method that we approached it from. That we didn't need this geo-redundant because it wasn't our primary storage platform. It wasn't the platform where we tell people to store data that is critical to the university. If you have data that's critical to the university, you're supposed to store it in Google or Box. And so that's kind of how we approached it. So we don't think the East Zone is going to implode tomorrow, but if it did, we'd probably have bigger problems than that. But so that's just how we approached it. If we were saying mission university critical data is stored here, then we might have approached it with a little bit more zone redundancy. But we didn't, because it's not where we tell folks to store this type of data. It's all it's all in that analysis of what do you want the service to be, and how does it line up with other services, right? It's all in that kind of analysis. So. All right, any other questions? Thank you.
We'll give Phil an extra minute just to decide. Kidding. All right, everybody, have a great day. Let me go ahead and turn the recording off.